I am Anil Kumar, and in this video I'll explain you how to simplify radicals. We have 4 examples here and we'll do one by one all of them. You can also note them and try them yourself. You can pause the video, solve and then see my solution. Now whenever you're working on radicals, then what you should remember is squares of numbers. For example, you know what is 1 square. 1 square is 1. What is 2 square? 2 square is 4. 3 square, 9. 4 square, 16. 5 square, 25. 6 square, 36. So for our examples today, these will be enough to work with. Now, what is the square root? If I do square root of 36, I get 6. Square root of 25 is 5. So it's kind of reverse of square. So that I hope you understand. And with this in mind, let's try to simplify the radicals. Now, when we are trying to simplify the radicals, the strategy is to break down these numbers in the form of their perfect squares. For example, 50. 50 could be written as 25 times 2. Why did I take 25? Simply because 25 is a perfect square. So I'll write 50 as square root of 25 times 2, right? Now similarly, I'll break down 72. 72 can be written as 36 times 2, right? So 36 times 2. Well, if you don't get them direct, what you can do is you can prime factorize them. So they are even numbers, they could be divided by 2, and the next number you get is 36, which fortunately works for us. It is a perfect square. Now once you get to this step, then we know square root of 36 is 6, right? And square root of 25 is 5. And therefore, we can simplify them further and write these radicals as 6 square root 2 plus 5 square root 2. I hope you understand this step. What I'm doing here is 25 is the square of 5. So I'm taking 5 outside the square root sign. Since 5 square is 25 and square root of 25 will be 5. It is reverse. Square root of 25 is going to be 5. Do you see the operation? So square root of 25 is 5. That is what I've done. Now we have square root and square root both are similar terms. So we can combine the like terms. Once we combine the like terms, we get 6 plus 5, 11 and square root of 2. So that is our answer. I hope you understand and appreciate how we've done this. Now let me do the same operation once for these two. 27 can be written as 9 times 3. Why did I select 9? 9 is a perfect square. Do you see that? So I can write 27 as 9 times 3, and similarly I can write 12 as 4 times 3, right? Now since 9 square root is 3, I can write this as 3 square root 3 plus 2 square root 3, right? And now we will combine them as we did here. And we can write this as 3 plus 2, 5 square root 3. I hope by now you have understood the method. So you can still pause the video, do these two questions yourself, and then see my suggestions. Now let me work on these. Now it'll be a bit faster. Square root 32, that means we can write this as 16 times 2, and square root 18 can be written as 9 times 2, correct? Now square root of 16 is 4, so we can write this as 4 square root 2 minus 3 square root 2. When you combine them, you get just square root 2. 4 minus 3 is 1. 32, you know, can be written as 16 square root 2. So we'll write 32 as 16 times 2. And 8 can be written as 4 times 2, correct? 16 times 2, 16 square root is 4. So this is 4 square root 2 minus 2 square root 2. And that leaves us with 4 minus 2 is 2, 2 square root 2 as our answer. I hope with this set of examples you've understood the basics. How to add and subtract radicals, right? So in this, we had similar terms and kind of similar square roots. So I took it a very simple example so that we understand the concept. Now we'll move on with slightly more complicated radicals, and I hope you're ready to take that challenge. Thank you, and let's go for it.